safe as you visit Kenya's magnificent beaches. Holidays can be short, don't make life that short. Kenya Maritime Authority ensures your safety in the Kenyan waters. Are you playing your part? Wear your life jacket before going on board. Keep a close watch on children when swimming. Do not stand. Refuse to board a full boat. Stay away from the waters if you're drinking alcohol. Holidays are fun, but don't make it this the last time you enjoy. Kenya Maritime Authority ensures your safety in water. Our call and rescue center is open 24 hours. In case of emergencies, call.
Build them a house that years can't touch. Build them a home that makes them feel safe and loved. Build them a house that lives up to your dreams. When you build a home, build it with Nguvu Cement from Bamburi. That is reliable and trusted to build durable structures. Because homes are built to last forever.
Awesome. Brought to you by Kenya Engineer, Kenya Maritime Authority, and Bamburi Cement. Awesome. Everything around you has been engineered. Are you tired of reading sensational news items on government contracts? You know, the propaganda type of I don't know what the bank has given some billions to some road projects. You know what I'm talking about. Are you in need of in-depth analysis of how engineering has influenced Kenya, or rather revolutionized humanity? And of course, you've heard about the Malaysias, the Singapores, the tattoo cities. Do you want to know the story behind the tragedies, collapsed buildings, or know the mightier power in those Kawasaki engines? Or passionate about technology and innovation, the iWatch thing, the Akina CGR, the Storos, ati how can railway be standard and have gauges? Or are you looking for tenders, engineering jobs, suppliers? Then join the Kenya engineering community. Get a copy by dialing 0719-207712 or join the Kenya Engineer online community www.kenyaengineer.co.ke. Clean water for all by 1998 or even 2002. That's a campaign slogan that you and me are familiar with. You must have heard it when you're about 10 years of age. And today, the big question that the country grapples with is the inequality in accessing clean, quality water. Did you know between 2000 and 2010, deforestation in Kenya's water catchment areas was estimated at 28,427 hectares? Water provisions is currently handled by regional water boards. About 13 million of Kenyans have no access to clean water. About 19 million Kenyans have no access to improved sanitation. With the consensus that engineering is a powerful mechanism for promoting social and economic growth, the Kenyan engineering fraternity remains largely underserved and underutilized. It is important to point out that there are no silver bullets that can solve inequality in water or rather solve any of our socioeconomic problems to realize a high-quality life. However, there is tremendous potential to help overcome these challenges through engineering, science, innovation, and technology. The engineering capabilities in water are wild and wide, ranging from taming floodwaters for irrigation to generation of electric power. The wastewater management systems, sanitation, and sewer lines are an integral part of the engineering solutions being offered in the water sector.
Water is this country's biggest problem. And in many, especially in the rural areas, as we all know, the amount of time and effort and energy that people put into getting water every day means that they really can't be very economically productive doing other things. And so the provision of water is a fundamental requirement for economic development.
Quantity and quality of water supply depends on the water potential of a country. In Kenya, 647 cubic meters of renewable freshwater per capita exists, with a safe abstraction rate estimated at 193 million cubic meters.
Standards that are not very onerous in terms of international compliance with international obligations, but are able to ensure that the people are safe.
Kenya is classified as a water-scarce country because we are yet to attain the global mark of 1,000 cubic meters per capita. With increased population and continued depletion of water resources, our water potential may drop even further per capita.
The ministry, which basically deals with the policy direction, and then we have the regulator, which regulates the entire water sector, and then we have water companies, which are formed by different water service boards to do the actual service provision. Water Resources Management Authority, that is also one major player, and it involves in ensuring the water sources are really fairly protected. And finally, we have Water Services Trust Fund, which is actually financier in the water sector.
We have since put in place various mechanisms, various strategies, infrastructure development and regulation, so that as of the end of 2014, water coverage in the urban areas in Rift Valley is at 72%.
The history of domestic water provision in Kenya can be traced back to 1929, when the first Water Act, dubbed Water Ordinance, was adopted. In 1972, the roles of policy formulation, regulation and service provision in regards to water were accorded various ministries, like Ministry of Water Resources, Management and Development, National Water Pipeline and Conservation. In 1974, National Water Master Plan Initiative was launched to enable availability of water to households by the year 2000. It was dubbed Water for All by the year 2000, and it was managed by the Department of Water Development. This department was later to be known as the Ministry of Water. In 1997, it published a guideline on how to hand over rural water supply systems to communities. This would make the communities custodians of water schemes. The method used for legibility of a community was in its ability to pay, operate, and maintain the system. By 1999, a national water policy was developed. In the year 2000, 73 piped urban water systems had been developed and served 1.4 million people, and 555 piped rural water systems served 4.7 million people. During this time, safe water supply in urban areas was at 57% and 42% in the rural areas. Sanitation in urban areas was at 95% and rural areas at 82%. By the year 2002, just 10 out of the 555 water schemes had been handed over to the communities. In the year 2002, the water bill was published, becoming effective in 2003. At this point, it became apparent that something was not working right. All the targets that had been put in place seemed unachievable. What was the missing link? An engineering solution. One of the steps that engineers took was to conduct intensive research on the current water shortage, the current water source potential, and the target population.
We are developing new water sources which will supply E10 and Tambaj and the environs, 4,200 cubic meters per day of water, depending, for example, the sources, various sources of water. Energy is a bit expensive. We prefer getting water by gravity.
Kenya has several large-scale water uses. These include irrigation, industrial processes, and hydropower production. National Irrigation Board has set out to irrigate 1.75 million acres Galana and Kulalu ranches with a view of optimizing returns from the areas. Engineers will have to apply ingenious solutions to pull off this feat. To satisfy the demand for industrial-scale water consumption, Kenya has several water catchment areas which include Mount Kenya, Aberdare Ranges, Mau Forest, Mount Elgon, and Cherangani Hills. These water catchment areas are, however, under threat because of destructive human activities and encroachment. Currently, there are no efforts towards conserving these areas and using them for sustainable water provision. Effective management of these catchment areas is vital, as they are needed to keep supplying water to streams and rivers that enable agriculture and other large-scale water uses. River intakes, large dams, and reservoirs are the main sources of piped water for domestic and industrial consumption.
Water table is dropping, and this is a phenomenon that is common throughout the world wherever there is high demand, even in Europe. So what that means is that the pumps obviously the boreholes need to get deeper, and the pumps need to get bigger in terms of the power that they need. There's not a huge amount of groundwater available, especially in the northern arid areas. And so most of it, surface water, and so most of it is groundwater. And it is, if you do have surface water availability like you do maybe in better water countries like Uganda, it is much easier to provide water for the population.
Now, when you look at Hala Park, you see a very beautiful harmony between the industry and nature, coming from mining and environmental management. Most of the time, industries fight nature, but here, it's a big shock.
And mining took around 17 years. That's 54 to 71. After mining, now the land became very hostile. That is, some hostile conditions were existing here. One, temperatures shot up about more than 40 degrees Celsius. Again, humidity also went up, and the area was completely left bare without any topsoil. In some areas, the excavators had gone as deep as cutting the water table. Now, for these reasons, back in 1971, Bamburi took the initiative to rehabilitate. The idea behind was to create an environment which was actually conducive for the business continuity. And not only that, but again, in the process, Bamburi wanted to create an environment which was actually for the livelihood of the neighborhood.
In the second part of this program, we examine how water scarcity and poor sanitation affects Kenyans and how the engineer is rescuing the situation through engineering, innovation, and technology.
Kenya Maritime Authority, or short form KMA, is the government agency that's charged with the mandate of ensuring the safety and security of shipping, as well as the preservation of the marine environment.
Before taking that glass of water to quench your thirst, a bucket full to wash your clothes, or even a running shower early in the morning, has it ever occurred to you how that water gets to you?
The engineers who are working with this board, who have a big role, and who have embraced the idea of public participation.
We get into a source that can supply us water, we'll have to look at its reliability, carry out studies to ensure that the water supply is kept. Rather, the source can be able to sustain the water supply is kept during the deficit months when there are no rains and when there are rains. You have to ensure that you transport the water to the treatment plant. You have to ensure that the water can be adequate in terms of the level that you get to supply. The silt can be taken care of. The adequate water can pass through the pipeline. You can dam the water or simply use a weir to create a pond. You don't want to take all the dirt that the water comes with. You have screens, and these are basically supposed to filter the dirt. You screen it by having the coarse screen, and you also have the fine screen that now takes care of the small item. We have a pipeline that transports our water to the treatment facility. After we've dammed it, taken it through the screens, then we bring it to our treatment plant. So when it comes to the treatment plant, one major thing that we want to do is to control its velocity. You have a stilling basin, some energy dissipator that ensures the water when it arrives at the treatment plant, speed is controlled. Because the treatment process is very much dependent on the speed. Flow speed has to be controlled for you to get the processes right. So after passing it through the stilling basin and the energy dissipators, we take this one to the flocculation basins. The flocculation basin, basically this is where you get rid of the suspended items. You flock them together using a treatment process. You apply alum to be able to coagulate them so that they come together into clogs. And from the flocculation tank, the water moves to the sedimentation tank, where all the suspended items get time to settle down. For horizontal flow sedimentation tanks, where the items or the coagulated items settle through the movement process from the start of the sedimentation tank to the end of it. Then after that, we take it to the filters. Filters are to check also the turbidity of water. Turbidity in simple terms means the color of water. It has to be appealing. It takes care of that. And any other organisms, danger that would have remained in the water are filtered at that particular point. A rapid sand filtration system. There are two systems, either rapid or slow sand filtration system. Depends on the amount of water that we need to get out. So after the sand filtration system, the water moves to a clear water tank. Here you carry out chlorine dosing to ensure that any other pathogens that would be there are eliminated at that point in time. So the dosing is done at the clear water tank. Then the water can now be supplied, taken to its reservoir tank or a supply point where it can be distributed.
In rural areas, inadequate water supply has seen women and girls spend hours traveling long distances to fetch water, leading to a decrease in literacy levels, especially for the girl child. Water scarcity has also led to conflicts in some areas and famine in others. Poor sanitation, on the other hand, led to rapid spread of waterborne diseases. When it became apparent that water scarcity was affecting all aspects of life, engineers went in search of solutions. The engineers have a vital role to combat daily challenges faced by millions due to inadequate water and sanitation provision. Borehole drilling has been made easier through engineering technology like drills and pumps. Recently, engineers have been working hard to realize the exploitation of the Lotikipi Basin Aquifer and the Lodwar Basin Aquifer. This promise to transform the arid and semi-arid northern Kenya into the future food basket of the country through irrigation.
There's been a huge improvement in the last 10 years or so in the quality of engineering graduates coming out of the country. Borehole basically has two components. One is the borehole itself, which is just basically just a hole in the ground, and which is drilled by a specialist contractor. And once you've got that borehole, then it needs equipment to extract the water from it, and that's where we come in. We supply all the components for the borehole. Obviously the pump is the main one. The pump is suspended on piping, which we supply. It has a cable for its electricity supply. It has a control panel on the surface. So basically we provide all the equipment that goes in the borehole in order to provide water at the surface.
Before we get into a source that can supply us water, we'll have to look at its reliability. Carry out studies to ensure that the water supply is key. Rather, the source can be able to sustain the water supply scheme.
We have the Kenyan standards, also WHO standards of water treatment. So we treat water to acceptable standards. It involves removing all the impurities in water, making sure that it is safe for drinking.
We've got a whole range of equipment that deals with each of these conditions. So when a customer comes in, we obviously, the first step is to get a water sample and to test the water to see what the actual requirement for treatment is. And once we do that, then we can specify appropriate equipment. We have been in solar now for about, since more or less the turn of the century, so nearly 15 years, 14, 15 years. So we're sort of one of the pioneers in the industry. And there are two types of solar product. One is the hot water heater, which just converts directly the the energy in the sun into heat in the water, and that's one type of process. And the other technology is what they call photovoltaic, which is where energy from the sun falls on these modules, which then generate electricity.
Treating wastewater is a big expense, and today our engineers have devised stabilization ponds that rely on intensity of the sunlight and high temperatures. Achievement of all these milestones in wastewater management and sanitation has not been without challenges. As per the account given by the engineers, most of the challenges they face include finances, water quality, human conflict, and lack of clear policies to guide this sector.
In the water sector for many years has been actually the investment. There has not been enough investment in the sector, but since the year 2003 there has been a very increased level of investment in this sector, over 5 times that compared to what the current budget for the ministry in terms of development budget is over almost 40 million, and this is far much more than what we had in the year 2003. Communities also we had to hold. Case in point is where some of our officers were actually attacked recently in Garissa County, and this is really posing a big challenge to us in terms of timely implementation of these projects.
To ensure that ships are safe for cargo, for the passengers on board, and also that in their transport undertakings, they do not introduce harmful elements into the environment. For example, they should not dump waste, sewage, or other operational waste into the water as they move about their business.
Water is scarce. Getting even the source of water is a problem because population is increasing. If the water is available today, is enough today, it's not going to be enough tomorrow. Encouraging people to be able to harvest water, rainwater, so that at least you can be able to blend with water from the boreholes.
The engineers have the skills and knowledge for this, and with ample resources, there will be improved sanitation and better wastewater management. Effective management of wastewater is vital for a clean environment and sustainability in water usage. Domestic water management systems should also be adopted to help manage the scarce water resources. Domestic water recycling systems and biodigesters can cut household water consumption by almost a third.
We work with here are mostly water services engineers. These are have basic training of civil engineering, but more focused on water infrastructure development and also water services distribution. The engineer is a very key person. Of course, we have other professionals as well, but an engineer is always a key person in the delivery of water.
Water is a necessity, especially for development. It ensures good health due to availability of food and sanitation. It ensures the productivity of Kenyans. This cannot be overlooked in the quest to achieve Vision 2030, as people in the right scale of mind and health are a key factor to its realization. Stakeholders in the water sector have expressed hope that the proposed water bill will bring positive changes should it be passed by Parliament.
Restructures the industry. I think it's a much better arrangement. I think that it gives it localizes responsibilities and both for the supply and the investment in water resources and the supply of water, and there is great improvements going on in the whole sort of structure of the water provision industry in the country.
Meanwhile, the engineer will continue to work towards the achievement of effective and efficient water supply and environmental-friendly sanitation. Engineers have dedicated the March-April issue of Kenya Engineer magazine to review progress and outline more solutions to water challenges in the country. The future of water could be H2O.
Build them a house that years can't touch. Build them a home that makes them feel safe and loved. Build them a house that lives up to your dreams. When you build a home, build it with Nguvu cement from Bamburi that is reliable and trusted to build durable structures. Because homes are built to last forever.
Stay safe as you visit Kenya's magnificent beaches. Holidays can be short, don't make life that short. Kenya Maritime Authority ensures your safety in the Kenyan waters. Are you playing your part? Wear your life jacket before going on board. Keep a close watch on children when swimming. Do not stand. Refuse to board a full boat. Stay away from the waters if you're drinking alcohol. Holidays are fun, but don't make it this the last time you enjoy. Kenya Maritime Authority ensures your safety in water. Our call and rescue center is open 24 hours. In case of emergencies, call